Okay, so this is the part 2 of the review, and here we are going to look at the reaction stoichiometry. All right, so reaction stoichiometry, first of all, let's look at a simple one. So here, in this case, what are we going to test? We are going to test, number one thing, balancing. Can you balance? If you have not balanced, you know, the whole, everything goes wrong. So balancing is very important, okay? And then the rest is, you know, obviously, can you calculate the molar masses? This is what we're going to apply here and test. Can you convert grams to moles? Can you convert moles to grams? All this is applied here, right? Um, do you understand the concept of mole to mole ratio? Okay, so this thing, all this is tested here. Okay, so all this is like can be included, will be included one big question, but it can be broken up into small parts also. So let's first of all break it up into small parts. Balancing. Okay, so let's look at this as a one question here. One question. Okay, so here is nitrogen, and this is hydrogen, and when they react together, they give you NH3 ammonia. Okay, so you are given, let's say, 5 moles of nitrogen. And the question is, how many moles of ammonia is produced? How many moles of ammonia, okay, is produced? So that's the question. So first thing first, generally the questions will say balance, but it's a common sense, it's a common habit that we are going to balance it. Okay, so here we see how many nitrogens? 2 nitrogens. How many hydrogens? 2 hydrogens. Here 1 nitrogen and 3 hydrogens, right? Everyone get that? Now we have a scenario where we have the nitrogens not balanced and hydrogens not balanced, but there is an odd number, right? So we will look at anytime there are odd numbers, you always look for common multiples. Okay, common multiples. And what are those common multiples? Example is 2 times 3 is equal to 6. 3 times 2 is equal to 6. 2 times 5 is equal to 10. And 5 times 2 is equal to 10. You get that? So these are the common multiples generally, right? We give like that. So here we have to make it 6 now because it's 2 and 3. Okay, so there is 2 nitrogen. So if you put 2 here, this 2 applies to nitrogen and this 2 applies to hydrogen. Okay, so now we see this is 2 times nitrogen makes it 2 nitrogens, and 2 times 3 hydrogen makes it 6 hydrogens. Okay, so now we have 6 sorry. Okay, so here we have, oh, why does it do that? Okay, we have 6 hydrogens and we only have 2 hydrogens on one side. We have 2 nitrogens here and 2 nitrogens. So at least the nitrogens got balanced. But to balance hydrogens, what are we going to do? We are going to put 3 here. So when you put 3, this 3 applies to hydrogen. This 2 I was already applying to hydrogen. But 3 times 2 is equal to 6 hydrogens. So that balances the hydrogens also. So 6 hydrogens, 6 hydrogens, 2 nitrogens, 2 nitrogens. So there are going to be questions on balancing. Okay, continuous. Everybody get that? Any questions on balancing? I'm going to do the balancing with polyatomic ions also. So this was a simple one. Okay, now this question is going to test your understanding whether which of, so these are the mole to mole ratio questions. Okay, so let's look at all the moles here. So mole to mole ratio, and this is also called molar ratio. Okay, molar ratio. Okay, now here we see that 1 mole of nitrogen, this is 1 mole of N2, this is what it's called. So this means 1 mole of N2. Okay, 1 mole of N2. Clear? This means 3H2. H2, this means 3 moles of H2. Okay, And 2 NH3, these coefficients, right, means that there are 2 moles of NH3. But what you see here, these are the 2 nitrogens, the 6 hydrogens, the 2 nitrogens and 6 hydrogens. These are individual atoms or individual moles present. Remember, that is why I made this one. I think I made this one though, right here. Right here. So 3 moles of chromium, 2 moles of phosphorus, and 8 moles of oxygen are present in Cr2PO4 whole twice. So same is the case, individual mole. So don't get confused between when it says the nitrogen, a single atoms is different, but this is different. This is different. This is N2, this is H2, and this is NH3. So these are full-fledged, molecules. Okay. So there is a difference between N and N2. N2 is a diatomic molecule made up of 2 atoms. Diatomic molecule. It's made up of 2 atoms. And N just by itself is an atom. Clear? Okay, so so don't get confused. Now, our language, this is our language. Instead of writing those big sentences, what do? We can express the whole thing as mole to mole ratio. So let's look at the mole to mole ratio of nitrogen, N2 and H2. H2, okay? So that's the mistake students make. Sometimes they don't, let me see if I can bring this. Oh, sorry. Oh, hold on. How do I? Oh, how do I get this? I'm sorry. Just a minute. How do I make this small? Okay, hold on. Why did
I think
does anybody know how to make these small? Zoom recording. Okay. So if we are looking at mole to mole ratio, so we are going to write down as 1 mole. So it is also can be written as N2 over, just to like a short form, over 3 moles of H2. Okay, so these are the 3 moles of H2 over 1 mole of N2. These are the short forms, or like instead of writing mole in between, but that's what, this means the same thing. Okay, next is the other relationship is between the nitrogen and ammonia. So nitrogen and NH3. And the third one is the relationship between hydrogen and NH3. So all these ratios you can write. Got it? So here nitrogen is 1 nitrogen over NH3 is 2 NH3. And these are the conversion factors also. So mole to mole ratio is also called a conversion factors. Conversion factor. Okay. Now conversion factor here. So 2 of NH3, 2 moles of NH3 is coming from 1 mole of N2. Similarly, there are 3 moles of hydrogen and they are giving you 2 moles of NH3, and 2 moles of NH3 are produced when 3 moles of hydrogen are reacting. Okay, so these are the conversion factors. So another type of question can be asked. Now let's look at if we are given 5 moles. So all this information you should know before attempting this question. And it's a very simple question. The question is asking you're given 5 moles of nitrogen. How many moles of ammonia will be produced? So we want ammonia and we are given nitrogen. So we are going to look at the relationship of nitrogen and ammonia. These are the 2 things we are going to focus on, nitrogen and ammonia. Okay, so out of that, we want the moles of ammonia. So out of these two, this conversion factor is going to be used, which will allow you to have the moles of ammonia in the numerator on the top. Okay, because you want to know about. So this is your want. This, oh, okay. So this is the want. So want will remain on the top. So want top. Okay, so then the rest is easy. So now let's calculate this. So 5 moles of N2 times. Now we need to find the moles of ammonia. So from the balanced equation, there are 2 moles of ammonia being produced when 1 mole of nitrogen is reacting. 1 mole of nitrogen. Okay, so what do you see here? You see that in this case, the moles of nitrogen cancel out. Okay, and this is what you want. So that is why this remains on the top. Okay, and these cancel out. And what is left next is 5 times 2 divided by 1. Okay, let me erase this, make it nice. 2. Okay, so what do you get here? Answer is 10 moles of ammonia. Okay, got it? So you will have to write down, this moles is a unit. So you will have to write down the unit, and you're going to write down the species, the chemical species. So chemical, like the chemical formula of the substance, or the species, whatever, it's the ion or whatever, okay? So that's the way you write down, and then you write down this is the answer. So don't write down just 10. Write down the units and the chemical species or the formulas, okay? All right, so this was very important. This type of question will be on the test. Okay, got it? Now let's look at the second one. Second type of question is, let's do second, and that is, let us say you are given zinc nitrate. Okay, zinc nitrate reacting with KOH, potassium hydroxide. Okay, so this is going to give you, what is it going to give you? Let's do that also. Outer, outer, inner, inner. So it's very important you recognize the polyatomic ions. OH is a polyatomic ion. Recognize the metals. This is a zinc metal. This is the potassium metal. Okay, so zinc and OH. And potassium and nitrate. All right, got it? So what do you get here? Write down the answer, the products. So this type of question also is a part of this. So products, balancing, solubility, okay? And then we are going to do here the reaction stoichiometry. And I'm going to do the ionic and net ionic later. Reaction stoichiometry means mole to mole thing. So what is formed? Okay, so Li, zinc hydroxide is correct, but the other one is not. Remember, metals are always written first. Metals are always first to fix it. Yeah. Perfect. Very good. So zinc is in transition element. Okay. Zinc is transition element and it belongs to the D block, right? So this is going to be having all the time by default. It does not have it a variable, but it will have +2 charge. Nitrate is a polyatomic ion -1 charge. Okay, potassium is in group 1A, and so the charge is going to be, it's an S block, so the charge is +1. And then the other is a OH minus. So OH and wait a second, nitrate. So that's something you will have to memorize. Okay. They have really, whenever they do these updates, it's not necessary that it's going to be a better product. It becomes even worse than before. This eraser thing is so, like, every time I have to go back and back and forth through erase, and it always takes you to the last whatever. It's not necessary like these upgrades are best. So anyways, so here we have the nitrate, as I was telling you, nitrate -1 and OH -1. So this is something you need to memorize, okay? All right, so with that said, just for the rest of the class, so zinc +2, nitrate -1, okay? First, you ionize them, so they are going to give you like zinc plus and nitrate ion. And then you have KOH, K +1 charge, and OH -1 charge. This is K, okay, K +1. So now, as I was telling you, outer, outer, inner, inner. So this zinc is going to connect with the OH. And potassium is going to connect with nitrate. But always metals are written first. Okay, so with that said, we now have ZnOH whole twice, right? Because it's coming from Zn +2 and OH -1 crisscross. This number comes here and this number goes here. And that's why you have this guy. Next is you have another one, which is potassium +1, and you have nitrate -1. So plus and minus cancel out. That gives you KNO3. And always metals first. Metals are written first, and then the non-metals and polyatomic ions are written second. Okay, now, all right, now what do we have? So we are going to now write down the full equation, and the full equation is zinc nitrate and KOH, zinc nitrate and KOH, KOH gives you ZnOH whole twice plus KNO3. Okay, so that's the second question about, so the kind of question, like I said, identifying the products, then balancing. So let's look at the balancing now. Now, in this case, I mean, it is okay since we have these polyatomic ions to leave them intact. So keep the polyatomic ions intact. They are the same on the reactants and the product side. So how many nitrates do you see on one side? How many nitrates? There is one zinc. There are two nitrates. Yes or no? Does anybody think that there are three nitrates? Anybody thinks that there are three nitrates? I see that question a lot. No, right? So there are one zinc and two nitrates, okay? One potassium and one OH, right? It's actually the same thing as this, as the, when you are like writing the product. It's the same thing. It's the same thought process. It's just like you are like I told you, it's like building a schema in the brain, okay? So here is the zinc. there's only one zinc, but there are two OH. Here there is one potassium and there is one nitrate. Okay, so zinc plus 2 charge, nitrate minus 1 charge, potassium plus 1 charge, OH minus 1 charge, zinc plus 2 charge, OH minus 1, potassium plus 1, nitrate minus 1. Okay, now 2 nitrates on one side, 1 nitrate on the other side. So if you put 2 here, this applies to potassium, applies to nitrate. So 2 and 2. So this gives you 2 potassiums and 2 nitrates, 2NO3 minus 1. Okay, so 2 nitrates are balanced, but potassium got messed up. So now you're going to put 2 here, 2 potassiums and 2 OH. So this gives you 2 potassiums and 2 OH. So this makes it 2 potassium plus 1 charge and 2 OH minus 1 charge. Okay, so you have, in this case, 1 zinc, 2 nitrates, 2 nitrates, 2 potassiums and 2 potassiums, and 2 OH and 2 OH, all balanced. Clear? Okay, so this is one thing, and so it's okay to rewrite just because I showed you this becomes a little bit messy. So NO3, now your turn. Everyone, look at the solubility table and tell me what are the solubilities of these compounds, all of them. Yeah. Solubilities. Zinc nitrate. What is the solubility? So it's soluble, right? Very good. So it's aqueous. What about KOH? KOH, group 1A. Remember, all nitrates are soluble. So aqueous. KOH, potassium, group 1A. All group 1As are soluble. So what does this become? AQ. Very good. Very good. Thank you, Daisy. Okay, zinc hydroxide. All hydroxides are? All hydroxides are insoluble except group 1A and ammonium and then barium, strontium, calcium, right? So those would be barium, strontium, calciums are partially soluble. But here, zinc hydroxide is insoluble. So this guy will be S. All right. And KNO3 is group 1A and nitrates soluble. So this would be aqueous. Okay, so this is another type of question where you would be asked to tell the solubility. Okay, got it, everyone? So I'm going to come back to this one. Let's finish because the total ionic is more or less the same. Or let's finish the total ionic also. Solubility, let me just put this here. Reaction stoichiometry is the same as that. So you will have total ion solubility, and here is the ionic, right? Ionic states, and then the moles thing, the mole calculations, stoichiometry. Okay, so everything we are looking into it. Now, so this is the molecular equation. Okay, this is the molecular. Okay, and next is the total ionic. Total ionic. And total ionic is what? You have zinc plus 2 charge, aqueous, plus there are 2, just like you balance it, it's the same thing. You're just basically copying it. That's all. Plus 2 potassium ions, okay, aqueous, plus, let me put this all in the separate line. Okay, so there is zinc plus 2 charge, aqueous, plus 2 nitrates, minus 1 charge, aqueous, plus 2 potassiums, plus 1 charge, aqueous, plus 2OH minus 1 charge aqueous gives you, okay, gives you now Zn. For the sake of balancing, right, it was okay to charge it, but you know, these will not charge when it's solid. So when you write down the total ionic equation, do not charge. Do not, you know, ionize or charge. Ionize means charge the solids, the one that is solid. And so in this case, it is this guy, zinc hydroxide. Okay, and zinc hydroxide is a solid. Plus, now you have 2 potassiums plus 1 charge aqueous, and you have 2 nitrates. Remember, this is 2 nitrates minus 1 charge aqueous. Got it? So this is the total ionic. And the last comes the net ionic. Net ionic is the ones that only show the change of phase. So we see zinc plus 2 state aqueous is reacting with 2OH minus 1 charge aqueous, and this gives you ZnOH whole twice solid. This is the net ionic equation, the ones that show the change of state. So ions, so you're going to write down all the species, whether it's ions or not, all the species, chemical species that show change of state. Okay, going from aqueous to solid, and it can also go from solid to liquid. It can also go from solid to gas, like in there are some examples also. But in this case, you know, for your course, solid is fine. Okay, so that's one type of question will be there. So now let's look at the the third part is the reaction stoichiometry. Okay, the third. Now, here we are given zinc nitrate, and let us say you take 2 grams of zinc nitrate, and the question is asking you how much of the zinc hydroxide is produced. So 2 KOH. So write down the whole balanced equation plus 2 KNO3. Okay, 2 KNO3 zinc hydro. So this is solid, and so if you are given, the question is asking you, after you balance it, always balance first. The question is saying 2 grams of zinc nitrate are given. How many grams of zinc hydroxide are produced? So given, this is the entity that is given, and this is the entity that you are going to find. Okay, find. All right. So what will we do here? What are the things that we need in this type of? So this is the A, and this is the B or AB, whatever, you know, this is AB. So like that type of scheme. So what are the things that you would need? Not given to you, but we expect that molar mass. Excellent. So for both the entities, because you need to find the grams. If they say find the moles, then you don't need the molar mass. But if they say find the grams, then you do. And the question will ask you to find the grams. So here, find the molar mass on the side, find the molar masses. Okay, on the side, molar mass, find. Or calculate the molar mass. Okay, do this. So we are looking at only 2 entities here. One is the zinc nitrate and the other is zinc hydroxide. These are the only 2. Okay, so we don't care about that. After you balance, don't worry about it. So now let's look at the zinc nitrate. So Zn brackets NO3 whole twice. And then the other one is ZnOH whole twice. So 1 zinc, 2 nitrogens. So 2 times 3 oxygens, right? And that is equal to 2 3s are 6 oxygens. Okay, so Okay, so here zinc is how much? Zinc is 65.38. So you can do times 65.38. It's okay to put it 65. There are two nitrogens and each is 14.01. It's okay to use it as 14. Oxygen is 15.99, so you can make it 16. Okay, so here is so 65 plus 14 to the 28 plus 16, 6 are 96, I believe. 16 times 6, 96. Okay, so 96 plus 28 plus 65, and what do you get? 189. So 189 grams per mole is the zinc nitrate. Similarly, you calculate for zinc hydroxide. So that's put that on one side. Okay, put that on one side. That is zinc hydroxide. Okay, so here we have one zinc and we have two oxygens and we have two hydrogens. Okay, and that gives you one zinc is 65, oxygen is 16, and hydrogen is 1. So you get 65 plus 16 to the 16, 32, and this is 2. So 65 plus 32 plus 2 equals 99. Okay, so this is 99 grams per mole. So always do this on the side. You are going to get some credit for it, at least doing this much also. Minimum. Let's say you got confused and make some mistake somewhere. And I'll tell you where the students make mistakes. So we are just focusing on two things, zinc nitrate and zinc hydroxide. And we are given 2 grams of this. We need to find the other one. So 2 grams of, so write down, 2 grams of what is given? You're given zinc nitrate, NO3, whole twice, right? First step is to convert grams to moles. So 1 mole of zinc nitrate, okay? ZnNO3 whole twice, okay? And that is equal to, zinc nitrate is 189. 189 grams of zinc nitrate, okay? So this is, to finish this, let's do it in parts. So this first step is to convert grams to moles. This is the first step. So if some people like to do it like, stepwise, you can do this way also. Okay, so 2 divided by 189, and that gives you 0.0105. Remember, I told you like 4, 1, 2, 3, 4 places after the decimal. 5, 8, there's 5, 8 also, but it's okay. Just leave it at 5. Okay, so these are the moles. These are the moles of zinc nitrate. Okay. Next, second step. Now we are going to find the mole to mole conversion. So mole to mole ratio, that's the second step. So in the second step, we are going to see that 0.0105 moles of zinc nitrate. And we are going to convert the moles of zinc nitrate to so moles of mole to mole ratio converts the moles of zinc nitrate to moles of zinc hydroxide. Moles of zinc hydroxide. Okay. All right. So here we see times here. Now, this part you're going to look in the balanced equation. So in the balanced equation, what do we see? We see that there are zinc nitrate and zinc hydroxide is 1:1 ratio, right? So 1 mole of zinc nitrate, zinc hydroxide is produced when, because this is what you want to find, moles of zinc hydroxide. And here is the zinc nitrate, NO3 whole twice, all right? So now you see that the moles of zinc nitrate cancel out. And you are just left with the answer here is, so it's 1-to-1 ratio. So 0.0105 moles of zinc hydroxide. Now, if you are, question is asking you, find the moles of, this entity, you stop here. But the question is moving further. The question is saying, find the grams of. So you're going to take the moles of zinc hydroxide, OH, whole twice, and convert it into grams of zinc hydroxide. Okay, so in this case, what do you see? This part comes from the balanced equation. Balanced equation. And if you don't do it, then that's where you make a mistake. Okay, so that's the most important piece. That's the mistakes occur here. So this is how do I write this? Okay, so that is, so this piece. Okay, now you take these moles of zinc hydroxide and convert it into the grams. So we have the moles of zinc hydroxide, 2 grams of zinc hydroxide. So we have 0.0105 moles of zinc hydroxide, OH, whole twice, times. Now you need to convert it into grams. So go back and look at the molar mass of zinc hydroxide, which is 99 grams per mole. So here you're going to write down, because it's a mole. So 1 mole is going to be at the bottom, zinc hydroxide, OH whole twice, and then here is the 99 grams of zinc hydroxide. Okay, so what do you see here? Moles of zinc, moles of zinc hydroxide cancel out, and you are just left with the grams of zinc hydroxide. Okay, so just do the math. 0.0105 multiply by 99 and then divide by 1. So this comes out to be 1.04 grams of zinc hydroxide. Okay, so these are the 3 steps. You can break it up into 3 steps, or you can do all of it in one line, as I showed in the class. It still will come through practice. So always calculate the molar mass first. First step is always grams to moles, always grams to moles. Next step is mole to mole ratio, which comes from the balanced equation. And then the last is converting the moles to grams. Okay. Let me write this down here. Moles to grams. That's the last step. Okay. So that's the answer. And that is one thing. And we can do the same thing applies to the limiting reactant problem also, like we did. But there is, so I'm going to give you one more. Well, let's just do one more. Okay, let's do, this was the reaction stoichiometry 5. So this was one example. Second example, third example of this, and let's do the fourth. Okay, and that's for the limiting reactant. It's exactly the same thing. The only difference is we look at that, species that has that gives you the lowest final product. Okay, so reactant. Okay, so I'm going to do one, and that is the last today. Okay, so this is the 4. This was what? 3, 4. Limiting reactant problem 4. Okay, so let us say, let's do a simple one. Let us say you are making HCl. So you take hydrogen plus you take chlorine, right? And that gives you HCl. So you balance it to, okay, 2 hydrogens and 2 chlorines. So just for the sake. Now let's say you are given, you use 10 grams of hydrogen, and let's say you are taking 10 grams of chlorine. Okay, so identify the limiting reactant, find the limiting reactant, find the limiting reactant. LR is that, right? And obviously with that, the theoretical yield, like how much in theory can you actually produce? Okay, theoretical yield, the amount. Okay, so that is the amount in grams, okay, of HCl. So it's in the limiting reactant problems, you compare the two products. You compare, sorry, the two reactants. Compare reactant 1 and reactant 2 to the product. So which one is going to give you the lowest amount? Lowest amount, the one that is giving you the lowest amount of product, that is the limiting reactant. Okay, LR is limiting reactant. So same story you're going to do on the side, calculate the molar masses and just leave them on the side. So here you have H2 and you have Cl2 and you have HCl. Okay, so there are 2 hydrogens, there are 2 chlorines, and sorry, 2 chlorines, and you have, okay, 2Cl, and then you have 1 hydrogen and you have 1 chlorine. So 2 hydrogens, so this is going to be 2 grams per mole. That's the molar mass for hydrogen. 2 chlorines, each is 35 grams. So this becomes 70 grams per mole. That is for the chlorine, Cl2. And then hydrogen is 1 and chlorine is 35. Okay, so you have hydrogen is 1 gram. Oh, what is that? Okay, here is hydrogen is 1 gram and chlorine is 35 grams. So the total becomes 36 grams per mole. That is the molar mass for HCl. Okay, so this, always do this on the side. Next thing, you are going to compare. So always write this down. You see, always, this is an important question. I'm telling you, this is going, all these questions that we discuss are going to be on the test. Different examples, of course. Okay, so practice them on your own. Okay. All right, now we are going to compare hydrogen, using hydrogen, and how much HCl can we produce? Sorry, HCl can you produce? Okay, so if you use 10 grams of hydrogen, how much of the HCl can you get? Now this thing, I'm going to show you, you can write this in one line. So 10 grams of hydrogen, first step is to convert 2 moles. Now H2, that is a mistake students make. Sometimes they just put H. No, it's H2 times. So I had like some students practice on the board after the lecture. And so, and in general, I see that common mistakes also. So 1 mole of H2, not H. So students make a mistake here. So pay attention to this. This is always going to be 1 mole and it is H2. So, like H2, that should match. Okay, so 2 grams of H2. So pay attention to that also. Okay, times mole to mole ratio of HCl. So this next step converts the moles of H2 to moles of HCl. Okay, so we see from this balanced equation, 1 mole of H2 is giving 2 moles of HCl. So here you go back. 1 mole of H2 giving you 2 moles of HCl. Okay, so this step is just mole to mole. And you can stop here. Sometimes people stop here, but let's move further. Get the grams of HCl. So 1 mole, this is always going to be 1 mole. 1 mole of like whatever the other entity is and the molar mass. So in this case, it is the HCl. Okay, so here is the, here. Okay, so now so this is always 1 mole, this is always going to be, so pay attention to these details. Okay, so that is always going to be 1 mole right here. 1 mole. Let me put this here, correct this. So this is 1 mole always. This is 1 mole always. So this, always pay attention to this. What is the middle part? The middle part is the balanced equation. Okay, so this part you are going to get from the balanced equation. So don't forget that this is the coming from balanced equation. From balanced equation. So that's why I'm saying, you know, if the equation is not balanced correctly, this is a mistake. So this part is the mole to mole ratio. Okay. And then this is, of course, the molar mass of hydrogen and the molar mass of HCl. So that is the molar mass of HCl. And this is also the molar mass of this other entity. And pay attention to, if this is hydro, whatever this is 2, then this would be 2. So that's a mistake people make. Normally, I've seen this and this. So these should match, okay? If it's just H, then you just do H. If it's H2, you do H2. If it's, you know, some, whatever it is, okay? So now let's get this thing. So now we see that grams of HCl, hydrogen cancel out, moles of hydrogen cancel out, right? Hydrogen. And then moles of HCl cancel out. Okay, so what are we left with here? 10 times 1 times 2 times 36. Divide that by, okay, 2 times 1 times 1. Okay, so what do you get? 10 times 1 times 2 times 36, and that is 720. Okay, 720 divide by 2, and that gives you 360. So 360 grams of HCl. HCl will be produced when 10 grams of hydrogen is used. Now let's compare the Cl2 to HCl. How much of that will be allowed? So same story, 10 grams Cl2, first convert to moles, 1 mole of Cl2, divide that by, Cl2 was 70 grams of Cl2, then come mole to mole ratio, 2 moles of HCl, okay, 1 mole of Cl2 times now 36 grams of HCl over 1 mole of HCl. Okay, so here as shown above also, this is giving you grams of Cl2, grams of Cl2 cancel out, moles of Cl2, moles of Cl2 cancel out, moles of HCl cancel out. So what are we left with now? We are left with 10 times 1 times 2 times 36. Divide that by 70 times 1 times 1. So what do you get here? 10 times 2 times 36 is 720. Okay. Divide that by 70. So 10.28 grams of HCl. So now you see, when you are using the same amount, when you are using the same amount, 10 grams of HCl and 10 grams of, so here we were using the 10 grams of H hydrogen, and we are using 10 grams of HCl also. So 10 grams of 10 grams of chlorine, sorry, 10 grams of chlorine and 10 grams of hydrogen. Okay, so we are able to, using 10, we are able to get 360 grams of HCl from hydrogen, but HCl we can only get 10.28. Okay, so here in this case, so chlorine also, 10 grams of chlorine will give us lower. So this is the lower amount. Okay, lower amount means that the chlorine, Cl2, is the limiting reactant. It's giving us the less amount. Okay, so then this lower amount becomes the the theoretical yield comes out from that. So in theory, no matter how much excess we are producing we can produce if we use 10 grams of hydrogen, we can only get 10 grams of 28 grams of 10.28 grams of HCl if we use 10 grams of chlorine. So we need to use more chlorine in this reaction in order to produce like a larger number of HCl. So we are limited now. So this is the theoretical yield. Okay. Now the last one is the percentage yield, 4.5. And this is the last, promise, we are ending now. Percentage yield. Percentage yield is, okay, let's say you do this reaction, and remember there are steps in the reaction. Okay, there are steps in the reaction. And the steps are what? The steps are like first you take the weight, and then you mix, and then you monitor the reaction, and then you quench the reaction. You do, there are certain processes: purification, crystallization, pouring things. So all those things, there's a productivity loss. So the actual yield is always going to be less. Actual yield is always less than the theoretical yield. Okay, theoretical is just in paper. Okay, so actual is always going to be less due to different processes, due to processes that lead to productivity loss. Okay, so there is always some amount is lost, the final product. Okay, so productivity loss is the cause behind that. So then what is the formula? Actual yield that you get in hand after you finish all the steps. So this is the real yield. Theoretical yield is just calculated on the paper. So this is the theoretical yield times 100% is the percentage yield. Okay, so actual, let's assume, so given in question that we finished all the processes and the final product we got was, let's say, 8 grams of HCl. Okay, this will be given in question. This 8 grams of HCl is the actual yield. Actual. Okay, so the question is saying find the theoretical yield, and other things will be given to you. So in this case, if you use 10 grams of 10 grams of chlorine, then you can only make 10.28 grams of HCl. So you're going to put 8 grams of HCl over 10.28 grams HCl times 100%. So 8 divided by 10.28 times 100. And that gives you 77.82%. All right, that is the percentage yield. And this finishes this entire review. So we really had to cover a lot, okay? So we have covered like all the important things many times, like the review has happened in the lectures also. So just go back and review. All right, I'm going to stop recording now. And if you have any questions, you can stay after this, okay?